Pretty much same story as last night. So you'll have new module available to you for tonight's session, and we go through it, I guess. Now, for this, you may want to use Abacus, but it's not compulsory. So I'll leave that up to you. How you're going to do with that. But in your final, you will.
已经画到来，我有差不多4个model for 以4个model for task，then 2D model 我画了 base model，then plane trace，then base model 就是你一开始要 compare 的，就是你一开始的 model， 然后 base on 那个 model 你要做 improvement。可以是一个我应该是都是一个都是一个不是一个 beam 啦。So 我的 base model for 我的 beam 是一条线，所以它只是一个 rod then second model 是我变成一个框，就是中间是空的 ，but then 它是then 过后再加一点 truss，then 最后再变成这个 final model。那个truss and beam model 是一开始是不给发的，到我加到那个 truss 才发。Then for base model，2D base model， 一开始就发了，把变成我要 improve。But 因为发了，我可以做一点点 improve， 刚刚好发就好，我就不会再改了。是普通人去不了的地方。
只有没有是男生必定要去的地方。男生必定要去的地方。But what is he there though? His jobs every day is intercom. Only today switch. Which one is that? Tampines you need to take a boat there or something. How come? I send my friend to Air Force. My friend go Air Force.
Okay, so going back to the actual final that you will do, they'll be asked to complete. So we talked about what's going to be first section. First section, direct interest method. This is basically what we covered yesterday. Tonight we're going to talk about structural elements. So we're going to talk about Abacus in general. So what you will be tested on is your ability to recognize how to model reality. So based on these problems, for example, the ones that we have here, you'll be given something like this. A bit of a story that describes the problem, and then you will be asked to model that in Abacus. So skill that we are assessing is how well you are able to convert reality into model, to do that in Abacus and interpret results. So 3 of those things. So for you to do that, basically you need to practice through these problems. What is the challenge here? Challenge is to recognize what are the modeling techniques, what are appropriate modeling techniques. When I say that, what I mean? Well, is it going to be truss, beam, 2D solid, 3D solid, 3D shell? So to recognize what is the best appropriate way to do that. Also to recognize where to put boundary conditions and what boundary conditions, as well as loads. And all other bits and pieces, like, mesh quality, mesh type, mesh element type, and so on and so on. So that's basically what you're going to be tested on. So, given a problem like this, how would you go about modeling? Obviously, because it's a part of structural elements, it's going to be either beam or truss. Yeah? So your question would be, how would you best model this?
A beam.
With the beam, yeah? So how many structural components would you have?
4.
You will have 1, 2, and 3. Yeah? So this one here would be beam. This one here would be beam. Question is why? Because both of them are bending, therefore they cannot be truss, they cannot be bar. But this one here, how about that one?
Truss.
It's a truss. It's a piston. It's pneumatic system, or hydraulic piston, or pneumatic pistons. Basically, it just goes in and out. Yeah. If you bend it, you'll wreck it. So this one here would be truss. So we'll have beam, beam, truss, for example. Yeah. It's very simple to recognize, because the way it's described in this problem is this bit here. It's a point load. In your test, it may not be as obvious. Yeah? You may have, I think next question is when you've got a load just attached to it, and then you have to figure out, well, something like that. Based on that description, you have to determine what is the load of appropriate load that needs to go on. So these are relatively simple problems. Yeah? So then you have to think, okay, how many elements? How many elements for this member? How many elements for that member? How many elements for that member? What sort of elements? Remember, we got truss, we got beams. Beams could be Timoshenko beam, and could be Bernoulli beam as well. So which of those? Is it going to be B22 or B21 or B31? Yeah? So determine that. Then once you run it, once you model it, then you have to go and interpret that. What are the relevant stresses? What are the relevant deflections? And what it means. Okay? So in this particular example, it tells you what are the limiting stresses. It tells you also what is the limiting deflection, so you can go and compare. Yeah? It says, okay, based on this, fluctuates sound, classes, requirements, and so on. Yeah? Now, let us do and model this in Abacus. Do you have all access to Abacus? You should be able to have that. As long as you have internet, you can log into my desktop, and then we can start modeling this. Yeah? It's fairly simple. Same as last night, we'll have someone come in the front and share their model and explain what they've done so we can talk through it, similar to what we did last night. And hopefully there's going to be different people than those that we used last night. Yeah? Okay.
6点知道没有？在哪里啊？说对了。
Okay, very simple to sketch it.
Stay side okay.
Use MM monitor.
MM or meter.
I use meter, but I put my size very small. You know when you can
Grid ah,
yeah, the grid. Yeah. Because if you put too big, then your MM very small. Then the MM very big, then the meter very small.
It's more plastic.
Hmm?
Plastic.
Okay,
100% recycle. So they recycle the packaging out.
yeah.
2D wire.
Yeah, 2E wire.
Cái nào cái gì ạ?
Cái bao nhiêu material? Determine the size of beam and column.
这个什么 this camera never allow. Block block. 什么意思？那个哦，我记得它就是就等来什么？I didn't care about it. At least it looks better than that. But the thing is, it still looks a bit weird.
Now, what you can see from this question, it is again design question. So we are using Abacus as a tool to help us to determine particular design. And it goes, determine the size of the beam and the column needed. Yeah, sizing of those two components, which will comply to those requirements. So very similar to what you're doing in your project. You have to find appropriate size, shape, geometry that meets the requirements. Here we've got two requirements. One is for the stresses to be so much or below a certain limit, and deflection of the tip to be below a certain limit. Yeah? So, and what are the things that we need to change, that we can change? We've got box section or wide flange section. So the profile is determined or given to us to be either one or the other. And then we have to play with the geometry, with the shape. Yeah? So when you've got a box section like this, you've got that size to play around with, you've got that size to play around with, and you've got a thickness to play around with. Same goes with the flange. You'll have certain parameters to play around with. It doesn't say what material you're Because again, as a designer, you would propose. You said, let me make this out of steel. Let me make this out of aluminium. So you'll have a combination, saying, for example, let's call this A, B, and T. So material, steel, A equal 10, B equal 15, T equal 1.
用冰。
So that's your first trial. You run it and you see that your stress is so much, that your deflection is so much. Is it below the limits? Yes, no. If it yes, how much below that is? Because it could easily be that this is oversized. Yeah? So if the, let's say,
它觉得这个 spin。
let's say D equals 0.01 and the limit is 10 millimeters. Silly example, but let's talk through that. So if the limit is on deflection is 10 millimeters and you've got a structure that deforms only 100th of the millimeter, what's that suggesting? Suggesting your structure is too strong, it's too heavy, too big. Yeah? So you can go back and change some values, so bring it a little bit closer to this. The other thing is, you have to be mindful of the role and the purpose of this. It's a crane. So crane is supposed to lift load, yeah, safely. But imagine like this is, if the actual beam is 20 tons and it's only supposed to lift 2 tons. You're going to spend lots of energy, electric power, whatever, just to move crane around. So think of the context when you're deciding on those parameters. Yeah?
So for material specification, everything we must sort out ourselves. Like
You can propose, yes.
Oh, that means this will be an open book exam.
Yes. So the question that I have here, I think it's worth reiterating. So your exam is open everything, open intent, open everything. So it's not just open textbook or the one that you can bring in. You can use any online resource you want. So you'll have full access to everything. So the question was where we have to find material properties. Well, you could maybe remember that what is the Young's modulus of the steel, what's the Poisson's ratio of the steel, what's Young's modulus of aluminium, and so on. Or you can quickly look it up and propose. Yeah.
What is 0.605y? What is y?
Yield.
Oh, U. That means the bending, the material bending, the yield stress of the material.
Yeah, 60% of it.
Oh, okay.
So this here is probably missing, could be sigma yield. So you go to 0.0605.
0.605.
Yeah, yield. That's supposed to be like that. So you find for your material, whatever that is, let's say yield is 300 megapascals. So your limit should be 60% of that. So the maximum stress should not be more than 60% of that. It's probably a typo. It shouldn't be. Oh, it is. S, no, it's not 6, so it is yield. So what it says there, like you probably can't see it, 0.60 SY. Yeah, yield stress, 60% of yield stress, not 5.
So, white flange section, can I assume is I-beam or?
So this one here could be box section, it could be flange. This same.
So which section is the flange section? I don't really get. Is it a I-beam or is it?
Yeah. So look it up. What it says, like in a wide flange section.
Okay.没有，我是用 Learning Edition。Learning Edition 是导入那个 Student Edition。
哦，用Student。我去买 desktop。
哦，对呀。
没有，我这个。
这个要等。
没有。
因为我配镜啊，我有看2个。
你是用什么？你有download那个器具谁？
这个有download。你是用 desktop 还是？
我用。哦。It's just not opening. You know what? Let me off my laptop on the desktop.
So for the truss, do we assume it's a rod or?
Well, with the truss, yeah, exactly. With the truss, we don't care what the actual profile is because we don't bend it. We just need to see how much cross-sectional area you have. Yeah.
Yeah. So to know how much cross-sectional area, we must know the size of the truss. We determine, is it?
Yeah, well, you can sort of assume what is going to be covered that much. Yeah. Because again, it is a thing that we are exploring. We put some numbers in and see what you're going to get at the end. That's my random numbers. You don't need to use those.
Sigma Y is the beam. This is to determine the design. No, yeah, it's the stress. That means, let's say you're using steel, right? The yield stress is 800 megapascal, so you need to use 800 times 0.6. Then when you calculate your stress, right, your stress cannot exceed 600 megapascal. Not 600, it should be 460. Sorry? I put 200 and... Oh yeah, shit, should be E9. Should be 250 E9. I put 0.3.
Okay, so probably you can't see it, but the values that I picked, they're not good. Okay, so quickly went through some numbers, and that's what I've got. So I assume you're going to have a steel 210 gigapascals or pascals ratio, and my box was 200 like that, 25 like this, and 5 millimeters thick. Did calculations, and I got a silly numbers, not silly numbers, but like, you know, I've got stresses of 5 gigapascals, and I got a deflection of 8 meters. So not good, yeah? So those numbers, they don't mean. So I need to go back, change the values, run it again, and hopefully get it right. Yeah? Does that make sense? Okay, so do you want me to show you what I've done and probably highlight a few things? Yes. Okay. Okay, so I can't yell too much, so please be quiet. So this is nothing new, but like, you know, let us revise that. So when you go and create part, you choose 3D planner, deformable, and you choose wire or structural element, because we are interested in those lines. We are not interested what is enclosed in. When we are dealing with continuum elements, we would choose shell, which means whatever we enclose with those lines is the actual material that we are capturing. So in this case, I picked lines, wire, and got a geometry. Nothing new in it. Now in property, I created material and used values. So again, we will be using only elastic material. So there's only two material properties that we are after: Young's modulus and Poisson's ratio. So we are not interested in yield or what happens post yield, all those things, plastic deformation. But you can, as a part of your design activity, you may say, my yield stress is going to be 400 megapascals. So we are monitoring stress to be below 400, so it remains in the elastic region. So my assumption is that every component here will be made out of the same material. It doesn't have to be, but my assumption is that that is the case. Then I went and I created two sections. One section is beam section, and other section is my truss section. You can immediately see the difference between the two. When you got a beam section, it's interested in profile. Why? Well, from your mechanics studies, profile, because beams, they bend, and profile is important. So I don't have anything here that's bendable. Oh, here. If you got a profile like this, so it's easy to bend, yeah? But if you have a profile like this, it's much harder to bend, yeah? So the profile, the shape of the profile makes huge difference because it's bending. That's why here we need to define what is the actual profile of our beam, of our line. When it comes to truss, we don't have that requirement. It only asks what is the actual amount of cross-sectional area. Why? Because truss does not bend. It's only getting stretches or compresses. Gets longer or shorter. Cannot bend. Therefore, profile is not of interest. When it comes to profiles, these are those design parameters. So I used, it was 100, it was 125 and 5. Obviously it turns out to be wrong bad assumption. Now, we got those sections sorted out, we want to assign them, yeah? So when you go to assignment, we'll probably delete these and do them again. We're going to assign, it says where you want to assign a what? Well, I know that's going to be beam, that is going to be beam, that is going to be beam, and that is going to be beam. So I'm selecting lines which will be beams, yeah? And I'm saying, okay, I'm putting beam section on them. So you can see here, that's sort of lime green, and this one here is sort of still gray. That's where my truss is going to be. So again, selecting that, done. Rather than choosing beam, I use truss. Okay, now everything is there. Remember now, difference between trusses and beams. Beam, it's just a line like that, yeah? Then we have a profile. Profile, let me sketch this differently. that's our line in space, like sticking out like that. If we have profile that is like this, we have to tell Abacus how that profile sits on that line. Is it sitting like that? Or is it sitting like this? Or some random orientation like that. So all those things are possible. To do this, we do beam orientation, yeah? And then that's this button here. I mean, obviously, like you've done it. And we choose our beam elements or beam sections only to assign those beam orientations. And that bit in properties is done. Assembly is easy, just bring one in. Step is just linear perturbation, so nothing new there. Load, well, if you go back to this problem, there's only one boundary condition, which means that this vertical, the column, is incasted, so basically fully fixed at the bottom. It pivots around here, so basically locks in at the moment when it's loaded. So there's only one boundary condition here. Yeah? So I've got incasta, sort of all degrees of freedom locked for that. And then for load, I have, what is that? Newtons. So we got 2.5 tons of weight, and when you convert that into newtons, it's 25 kilonewtons. Yeah? Right. Okay. Then we go to mesh. And then we choose mesh size. Now, what have we learned about truss elements?
The seat size should be big.
Pardon?
The seat size should be big.
Yeah. So, what we learned yesterday is like you got springs. It's almost like a chain, yeah? Now, the only thing that we can do to this structure is to make it longer or shorter, stretch it or compress it. If we bend it, it's not going to be happy. Why? Because every point here, every node is free to rotate, yeah? So, in our configuration that we have, because this bit here is our truss element, so we have to make sure that we've got only one element covering that component. You can't have more than one, because if you had another node there, you'll have a problem, because once you put a load, that node will just pivot. It will be hinged. Basically, this is hinged. That bit there is hinged. So just do that. That's basically what happens at every node. There, there, there. So you can't have a node in the middle for truss. Which takes us now, so truss sorted out. We talk about beams. Yeah? How many elements? Well, this goes back to this sketch that I've got here. Which of those two is beam? black or blue? Yeah. So why that? Well, basically that's what we expect out of beam. It means cross section is much smaller than the length. Yeah? And that's basically what defines beam. This resembles coin probably. Yeah? So why I'm saying this? Well, think about these lengths. Yeah? If my profiles were 125 and 5, yeah? So that bit there is 100. How should the length be then? Yeah, you can't have element size that is long only 30, yeah? That's not a beam. So beam, the way, you remember those stiffness matrices for spring that we did and so on. There's a similar thing for beams. And they are most accurate if we have a ratio that is roughly 1 to 7 or 1 to 10 cross-sectional area to the length. Yeah? So, in my case, I got a cross-section that's about 100. My length should be about 700 to 1,000. Thereabouts. Maybe even 500 would be okay. Does that make sense? Because, so what I got there, 500. If I had 100, for example, it creates issues. Yeah? First, it creates problem for beam. Well, we go back to this situation here. It's not even like this, it's shorter than probably something like that. Like a cat or build a box. Like that. That's not a beam. Because, as I said, profile is 100, length is 100. Doesn't look like this. Yeah? So sizing of the beams is important. But the other issue that we have is with this bit here. We got more than one. Yeah? We can work around that. So let us assume this is something that we want. Okay. But we need to resolve this problem. Yeah, we need to resolve this. So what you can do, you can go and assign local seed to it. Yeah? So we see that edge. Done. And we said how many? Well, we want only one there. And fixes that problem. But that doesn't fix the problem of the beam. But I'm saying, like, just in the future, if you got something similar, and if these are okay, and then you need to change for truss, that's how you would do. You would go create global for everything, and then you pick where your truss is and assign so-called local seed. Yeah? So we go back to what I had, 500. Now, we are not done here yet. So we click mesh, and then we need to go and make sure that we have correct elements assigned to it. Yeah? So we go here, assign element type, click on that, and we choose our beams. Done. And then you go and find your beam. Here it is. Now, remember when we talked about element types? See here, it says B21. Is it Bernoulli or Timoshenko? Or if I go and click here, it only becomes quadratic cubic formulation here. So it becomes B23. Is that Bernoulli or Timoshenko? So I see there were good options. It says shear flexible cubic formulation. Which one is which?
The default option.
The theory that you need to go and revise. Yeah? So shear flexible is Timoshenko, cubic formulation is Bernoulli. So that's that. Now we go and change our truss. You click on that, done. Instead of choosing beam, you go and find your truss element. Yeah? And you said, okay. Now we have beam there, there, and there, and here we have truss. Now we are good. Then we go submit a job, results, and then we go and look for S11, which is the actual stress that goes along the lines, along the beam, and we see that we got really, really high stresses. If you go and check displacement, so it's a vertical displacement that we are after, really, really high. So it means the structure is not that good. So I need to go back, change the profile. And go with something a little bit bigger. Let's say 300 by 100 and maybe 15. What else do I need to change? Because my profile has changed, my length of the beam needs to also change, yeah? But also we can increase the actual truss cross-sectional area there as well. So we can maybe go with more cross-sectional area, let's say 300. So we go to mesh, increase the length. There are some situations where okay, now we got something that's more like, so what was it? Do you remember 300, 115, and we got stress of 260 and deflection of let's say 60. Okay, now 60% of sigma yield is 240. So maybe I can make it 500, so it works better. So that's good. 300, and what is the other one? 360 of the length, yeah? So that's also good. Does this make sense? So you will be asked something similar in your exam, not exactly so open-ended as this one here. It'll be more sort of allocated, but it's still, you will need to do maybe one iteration or something. Yeah? But this is the idea. Does this make sense? Is everyone able to follow and build this the way similar to what I've done?
Right. So you only put one object
Only here at the bottom.
so X and Y. You want
And
to
Z, yeah, U1, U2, and UR3. Fully fixed.
So for the stress, we don't look at the Mises stress, right?
So for stress, that's another thing that you need to be mindful of. Well, you can use Mises or Mises, it's called, but S11 is more relevant. So when you got a beam, the stress that goes out of it like that is your S11. So it becomes more relevant than Mises. Yeah.
Sorry? Yeah, trust 不用 yeah, only the bottom of the yeah, only the bottom. Sorry? How to what? You need to first in the material, right, you need to assign two sections.
Yes.
One is beam and one is truss. Okay, so here, right, you need to go property. This one, the manager. Okay, so you need to create this. If you don't have this, you cannot run at all. So you need to go. Okay, just write beam section, truss section, both of them. Then you keep the beam. Then truss section, then truss. Then from here, you need to input one cross-sectional area. So you need to assume a cross-sectional area. So 你是 in mm 还是 meter? Meter 的话，我用 meter 啦 ，but 我的 cross-section
是 meter。
Okay, so my one 是100 mm rod 啦，so 我的是0.007。No 啊，这我 assume 的 ，actually 不用他，刚才他随便 just 丢一个300进去，我也不懂为什么要丢300。
他走太快，所以0.007。
Yeah，but 如果300的话是0.3耶，我也不懂他是用什么啦，but anyway，then 你再 create 多一个 for beam。Okay, so you create beam, yeah. So now you got, so this one is like telling the system you got two things, one beam, one truss. Then, okay, for beam, right, you need to press this. Okay, yeah, just to show what kind of beam it is. So 这个 question 是讲有 box, 所以我们就用 box. Just continue. Okay, 现在你就要 assign 它的 thickness 还有它的 width 跟它的。
这个。
没有，就是那个 box right. So 现在你跟他讲这个 beam right, or whatever beam 你要 select 是这样的，then 你要 assign 它的 length 跟 depth 还有 thickness.
How we get all this data?
他讲要 assume.
Yeah,
他讲要 assume.
Basically, meter basically cm your thickness.
Yeah.
这样我可以放0.2，因为这个没有人带这个。
Or is it meter? So you need to cm. Thickness of it.
No, just now you put in meter, right? So this one also need to be in meter.
No, my this one I put as in I assume it's 2 meter and.
Yeah, then it's meter.
Then
No, you cannot be 2 meter lah. This one, you realistic maybe 500, 0.5 or something. 0.5 is like half a meter.
Here leh.
Yeah, no, you just assume it's 0.5.
0.02 okay.
half.
Yeah,
It's 1 meter, right? So 0.5 is like half.
yeah.
Height then I also put as 0.5.
But this one doesn't mean that this is two split beam. It's just one beam. Then the truss is at 0.2. Okay, just assign anything 0.5, 0.5.
Same.
Yeah.
Then thickness I'll put uniform
Thickness, uniform, yeah. Then just assign any thickness.
Smaller,
Okay. Thickness must be less than half 0.005.
Yeah, maybe just put 0.01 at least 10 mm thick lor.
Yeah, okay.
Then so it's okay.
Yeah.
The stiffness all this okay.
See all this only. So after this one you close. Okay, now you need to assign. Assign is to tell the system which one is beam, which one is truss. So no, this one, sorry. Okay, yeah. Then okay, you need to highlight now. So now you want to assign a beam, right? So you need to highlight all that is the beam, yeah. All that you want to be a beam. All the stuff you want to be.
Push.
Okay, no, you 按 shift， 你 highlight 全部 just highlight 全部 shift highlight 全部。也是可以 OK， then 你 just 按 enter。I mean 你 just done 了。你刚才有 assign 了。对，这个 assign beam， yeah then OK。Then now you highlight this one。Then you enter, then assign extra. Okay, so now right, the system know right, this one is beam, this one is truss. Yeah, so now you go down. 现在要 assign step 还有 load. Assembly first, assembly first.
Then assign 它的那个
Yeah, great instance.
Just based on it or just okay within one.
Yeah.
Now after that assign 好了。
Sorry. I don't know why my nieces and S11 is so big difference. So I use everything in Pascal and meter. So my S11 I can withstand the bending stress, but my nieces fail.
So that's only like 16 megapascals.
16. Oh yeah. No, it's 16 megapascal. Yeah, which is 16 megapascal. 600.
No, it's 1/6. So like a very, very low stress.
Oh, okay. Oh, so this.
Your structure is very strong, very stiff.
Oh, okay. Oh, so isn't 6 mega? Oh, okay, I understand.
Step 要做完 step。
Okay. shit. Yeah. So step 做完了 right？ 你关掉。对 ，step 没有用的，只是跟你讲，他只是跟你讲，它有一个 force 而已。但不是 zero， 你 just 关掉，然后你去next 就是 load interaction 不用紧 load， yeah， so load is where you need to put the load on， so concentrated load， yeah， 你 just 放 load one， yeah， 这个一定要 step one， then 你 continue， then 你放在那边，你要 click， then done， 所以它就有 pop up right，so 这个是 x axis， 这个是 y axis， 所以这个是 in y axis right， 所以一定是 negative， 所以是第二个。
这个是 x， 这个是 y，
Yeah，
所以我
x 跟
这边要
y，
换零嘛。
这个不用放，你不用放，它会有姓名。
这个就是放。
then 这个你要 in terms of Newton 啊，一定要 in terms of Newton， 所以要打9.1。9.1。呀，你就要呀。
等下我就放 OK， 是吧 ？OK。它是往上的。哦，是对啊，我忘记它的那个地方。
有哪个地？
我要讲
你要去你的 manager， load manager， 呀这个。
Now, I had a question here. I think it's worth exploring. So it's in relation to these beam orientations. So you see the profile. When you define a profile, there are two axes. There's axis 1 and axis 2. Yeah.
So
here we've got
boundary condition.
2 going up and 1 going to the right. When you go and define beam orientation,
OK， 你回去，你看着你在displacement， sorry， 它是什
see
么
when you read this over
no.
here, it goes where does direction 1 is pointing. That's basically what it asks you to put in, yeah? And you're saying my 1 should point in 0, 0, minus 1, x, y, z, yeah? If you think of unit vectors, in which direction this points in z direction in negative, yeah? So remember, like, when you got a coordinate system like this, so you got x, y, z, yeah? So, and you got a coordinates x, y, z. If you got 0, 0, minus 1, where's the actual vector pointing? Yeah? So it is 0 in y, 0 in x, and it's minus 1 in z. That's your vector. There's that vector. So basically what you're instructing abacus is saying, I want my 1 to point in this direction. In the screen, when you click OK, that's what you have. That's basically what you're saying to abacus. You're saying, in this profile, I want it to sit like that. 1 going there, 2 going up. So it will be like this. If you change those numbers, you can control in which orientation is going to go. Yeah?
This is boundary condition, right? Yeah, then you just 放了， just 放了，没有画面。OK， anyway， 你回去你的 property， 因为 beam right， 你需要 assign 这个 beam material orientation 跟 beam orientation， 你要 click。
这个。
Yeah， 没有 hold， just click。then 你 highlight 全部 ，control A。sorry， 你这个不可以，你的 truss 不可以，要按 control， 你按住 control， then 你 click 那个线。OK， 可以了，then 你按那个，你then 你按这个，then 你 just 记得只要全部东西在 axis 区就好了，then just OK。then 你beam orientation 旁边那个，这个也是 just 按done，then 有 select 吗？要 select 吗？没有，你按对字。这是什么？beam orientation。OK， 你要 highlight 那个 beam， 全部的 beam。
全部。
呀，全部的 beam。你 Control A。等你 Control 你拉掉OK， 等你按单，等按 Enter， 再按OK， 等 Enter 多一次。好，你按单也可以。等你现在回去刚才你在你 load 是吗？你的旁边款机做了OK， 等你去下一个就是 mesh 了。So mesh right， 你按先你要 set 那个 size 先，按这个。什么？哦 ，sorry， 你要按这个 part 先。上面part OK， 等你按这个，等你按 apply 先。你 just 弄少一点，0.1咯，你 just 放0.1。你可以 apply。OK， 等你按 OK， 等你按这个旁边那个，这个是 individual OK， 等你 click 那个线，等你按单，它会有一个 pop up， 所以你按 by number， 按 1， then 按 apply， 按 OK。这个是 for trust 的呀，对。Then after 你最后你按这个按这个。哦 ，sorry， 你忘记assign 这个按这个先。你 highlight 全部的 beam， 弄掉那个 trust。OK， 你按单。Then 你这个你选去找这个是 beam right，OK， 那你按 beam。完了咯，已经select了。你 just 按 OK。Then 你按单。Then 再按多一次。for 那个 trust。你 highlight 按单。Then 你 scroll 下去 trust。Then 按 OK。Then enter。Then 你去第一个Then 你按apply。Then 按 OK。Then 你按第二个下面的，不是这个按 yes。按 yes OK， then 你就可以去 job 了，你就 submit 了。
sorry， 按错。
你要想用什么？像我的是小块，我的块是
我的转每个就是为什么这样空
你要做新的 job， 你没有做 job 它就空。我的 pack 是100，所以我就开我 for D square， 所以我的 D 是等你算出来它就会这个就是你要 assign 那个东西是要开始就自己要去算它的什么。如果是 square，
So that was like 100 meters. Yeah. Of course not gonna pay.
也是可以把你这个 cost 是如果有这个 cost 的话，它的 cost 是那个 cost 算。把另外一个 trust 的话，就是那一条线，你要它是什么东西？你要它是 long 吗？还是一个 square beam？ 所以你有那个了，你要算那个 cost。这是你的一个 trust 是一个 square 啦，咱都是一个 square， 就是500乘500，但是500乘500，还有这个 cost。
这个是好的。
对啊，complete 了就没有，你看一下吧，你把那个。
看一下，我随时反掉。
You press and push.
是太近了，successful 了是吧？
Yeah, successful 就可以让你，那你 just 按那个 color 那个 lens 的，你就会看得到。你是还在玩还是 drop down？
这边写的是
没有，你要回去那个 drop down。
Okay, so we got one more exercise and we're going to be done for tonight. Yeah?
就来你哦。刚才我们是讲说，在那个 property 呢
Yeah.
，property 上面不是有很多那些要什么？You apply yeah, you can make it
Yeah, you can click this, then you click the one. No, just one. The one you click the one. Then you need to click the. You need to click the. Yeah, then you press enter. Then you can choose this one. You can up the size, or you can just click by number on top. Then you just press one. Then apply. Now you go to the first icon. Then this one here, plus. Then you press the icon below. Then you just press it. Yeah, everything. Then you just go to drop it. But I think you got assign your favorite. If you just go your job, I think the job. You need to pick a job.
One important thing, it's worth remembering. Abacus does not keep units. So abacus, no units.
Yeah, you go this one.
No units.
Yeah, this two.
So it's you who needs to make sure that you're using right units. So options are newtons, millimeters, megapascals. Newtons, meters, pascals. So very easily you can mix them up, and all of a sudden you are out of order by 100 or million. Yeah. So keep track of those units.
The section is on axis 3. Always on axis
我的单秒之后呢，差不多。
你要那个 job 你要肯定的，你不可以按。
他已经搞定了。
把你刚才按了外，重新审。
我按其他地方，它要重新上面，把它重新上面。
你要重新审。你要等他回去肯定了。
What's happening?
Validate. Oh, they say the orientation again, is it?
Remember the story that I had before that I rubbed off?
You go for property.
When I
Yeah, you go back.
remember when I had this
Then you go.
and I said
Just not.
every point here
You press again the same.
is a hinge. It does this. This. Yeah. So what happens in your case, that bit there, you've got nodes in here that are hinges, they're just like in a wiggly. Yeah? So if you go in the elements,
No, 6 is not of this one, it's still all the 6. You press down. Press down. Just press down. Now continue. No, I think you can
It's too much of material and expensive, you know, that's another thing. Put it this way, like, you know, one way of viewing this, we are making this crane, yeah? And then we know it's going to be made out of steel, yeah? So 1 kilo of steel costs about $1. Yeah? So if you run your numbers and see how much of steel you're using, you can figure out how much material is going to cost you. Yeah? So if you make it really, really strong, really stresses are, let's say 5 or 3 megapascals, probably going to be too expensive to make.
你要去弄定你的那个 box， 还是你要 increase 你的那个 section area？
We'll have to put in density in order to do extract volume. Yeah? So I'm just hoping it's going to be here. Millimeters cube. So millimeter cube is 100 minutes. So you get here some more. So I got 39 cubic So what is the density of steel? About 7 point. Let's make it 6.
这个我就是说，如果要回去本地的话，我就是再回去按这个。
没有，你要关掉。
So if you go with these numbers that I've got, you'll have about 300 kilos of steel used in this. So cost me about, let's say,
那你这个
$400 in raw material. But if you make a little bit, obviously, bigger values, it's going to be more expensive. And your boss or your client is not going to be happy. Where is that super strong structure? How heavy?
他的每个格看起来都一模一样。orientation 是那个。
哦，你的 error 是 beam orientation 的。哦呀，你要去 beam， 你要去 property。
这个那个 N2 N1P 啊，这个也是。你那个有没有这个？哦，没有，因为你这个应该是没有问题。你看 ，OK， 你看全部的，全部没有全部的。可以按单，所以这个决定把是这里你要按的，一按掉就没有声音，你要按的，哎，你按 OK， 你再按，要再按单就行。现在应该必须装，对，也是可以。这个是 beam orientation， 你的那个 trust 有 assign as beam 还是有 assign as property？ 对，是这个，对，去 assign 这个。那个哦，你最多了，这个你只可以有一个，所以你没有删到的，它会有没有？啊，这个你没有删到，所以你这个要注意。真的，你要按钮后面。
好啦。什么不见？
没有，你要拍的是。这个也是后来出的，观察的。
我没事没事。
其实这 property 啊，你要做很多，一个要我 create material 了之后，然后我还得去 fix 它 ，create section， 还是 create section，run section， 然后 assign section，assign one section， 这个不需要 ，assign one section 就得去。local 就 material orientation 对啊，所以你的上来讲，我第一个和这个我需要先
Okay, so once you finish this problem,
我需要做那个 beam
very
contrast
quickly we're going to do extension
对
to
对，我就需要
to redesign that using
然
beams.
后就知道这边了。
呀，所以这个两
And
个
then
你全部 assign 就对了，全部 for 这两个
Compare
就
what
是
you're going
一
to
定
get.
assign。
Because that's basically what your project is about. So it's same problem, same scenario, same design, but one with the trusses, one with beams. This one here is with trusses. How would that look like if we were to use beams? Would it be exactly the same, or we can do something else?
我们也在这种看，我们是看的是最高的这个是吧？
呀，maximum
这个是
maximum stress bending stress。So as long as 你的 bending stress 没有，你的那个这个 bending stress 没有过你的那个 bending design stress 啊，你就是代表 OK。如果没有过的话，
这样 calculate 我的 bending design
你要懂那个 U stress for 那个 material， 所以你要去找你的 material U stress，which is 这个是megapascal， 这个是 U stress 是800 megapascal， 所以你要 convert times 他讲的 0.6， 所以你要把800等 0.6， 你就会拿480 megapascal， 480，呀。
哦，没有对啊，megapascal。
所以它是30 megapascal， 所以就讲 OK， 这个 OK 没有问题。
因为我们是它是这个是有写的是0.6 sigma。
0.6对，0.6 sigma y。
Allowable deflection is one
你就要看 U，allowable deflection 你要看 U。
U 是怎样看？
你要上面哦，你这里要按 U。
是 U 啊。
呀，现在要看 U1 U2。
这个是以 megapascal 也是啊。
所以你是用什么现在？
我这个他不是讲说 one over 这个的
呀，没有，这个是以millimeter，没有，这个是以meter，你放 meter right， 啊，这是以 meter。
我做这个的话就是
1 divide 1 meter， 你是 2 meter 吗？它的 bar 是2 meter， 所以你要打2 meter by 2 meter divide by 360。
哦，直接放0.005，0.005 megapascal。理论上来讲，我这个是可以过的，是吗？这是0.05 megapascal。
呀，应该是可以，我算不到。说这个 scientific term 有点难，我有点难以理解，应该是可以啊。
Would be 3 would be similar to the first problem that we did.
这个应该是2000的，这个如果是 megapascal 的话，5000 kilo megapascal 6 times 6。
You can have up to the horizontal and the structural
I
plan.
think.
Because then again, it is something that you need to explore. You know, if you have being sort of just sticks out of wall, stresses in the base of it will be much higher. Yeah. So if you sort of stick it out the wall, then you provide like a support like this. If you go a little bit smaller inside. So we don't actually try.
次是这样，他每次跟你说搞。So for this we design as a truss, right? Okay. Then for this one we don't need to care about the displacement, is it?
No. But obviously you don't want it to be collapse. Yeah.
Oh,
So it wants to sort of.
So as long as the yield stress can pass.
Not all displacement should be minimal.
Okay.
So it can allow a little bit, but not too much. It's a crane, more or less. Yeah? So it's a pulley, and you use this to lift things up. So if your crane does that, it's not a good job. Yeah.
So for buckling, how do we know whether the
Well, yeah, this is just like a design. In the abacus, you can't do that.
but we don't need to find like the critical buckling load.
So a good question here. This is straight out of design textbook. So it's more geared towards design, but you don't need to worry about buckling and finding critical buckling and all this stuff. But what we can do here, just like remodel this, do the sizing, making sure that tip doesn't move, and then figure out, because the whole idea of this exercise is also give you opportunity to play around with different sizes. So not all of them need to be of the same size. Yeah. So for example, this one here needs to be a little bit stronger or thicker than that one there, for example, or other way around. Yeah. So what you will do, you assign same for all of them. You run it and see what's happening there. You'll see some are red, some are blue. Those that are blue, they're probably too big, so you make that a little bit smaller. Those that are red, make it a little bit bigger, and so on, and you find optimal size. That's basically what they ask you to do. Cheapest and the lightest design. Yeah.
Yeah, correct. Yeah, 全部已经。 啊？
我们把之前的
因为 just copy and paste。
应该没有算。
you have to determine. That's the whole point. Yeah. You start off with the value and then you try to find what is the lightest option there.
No, you cannot. You cannot do that. You have to wait until everything, until the work completed is
20,000.
submitted. You must wait until completed is out. Then you can do it. So you cannot do that. You must wait. You must wait. But once you press, right, like once you press somewhere here, right, download something, maybe need to be something else for this.
Yeah.
That's the that's why very too long because of the 3D because damn long
Faster 的让我这个，我就是 copy from 这边就可以了。
Yeah, 也可以。
I fix everything initial, then I have to make it what it's supposed to be in the actual set.
Actually, 11 elements missing
Sorry?
11 elements have missing property definition. Job. Found. You found it.
I think because you just now click
No, I think that
didn't put the pin joint. The question when the pin joint is up, so all your no, actually this one is a so it's just spot sign what kind
From steel, it's the same carbon fiber, things like that.
But as it was just a designing if it's really just choose the piece, it's just and choose.
Okay, so here's the thing. So I just put some random values in. There's small profiles, all the same, and to see what's happening there. And we got stresses that are ridiculous. They are in 60 gigapascals.
Huh?
So obviously it's too
Everything
steep.
is on.
But that's good for now.
但我这个
The other thing that we can check is deflection.
不用，beam 不用。
And
这个
deflection
比较
is huge as
，trust 不
well.
用，beam
But
trust 不用。
let us go now back to stresses. Yeah?
跟我讲去的很没看。
And see what's happening there.
我觉得
Now,
真的不见得。
SMB
if we, in this case, we had all same cross-sectional area. So trusses are all of the same size. And obviously, based on their position, stresses in them will be different. Yeah? So what we can see from here is that this one here and that one there, they are stretching a lot. So stresses in them are really high. It's compressive stress. See, minus is compressive, plus is in tension. This one here is also very high. It's red, so red and blue are problem, yeah? Everything else, is okay. So we know that this one and that one and that one need to be really thick or thicker than any other. So they are most important parts or trusses in this structure. So in the second iteration, we'll go down. We'll say, let us give a special size to those 3 ones and see what happens there. Yeah? What are we going to say? We give it like, I don't know, let's say 300.
最好是全部啊，你管不管它有没有 rotation， just 跟它关掉就对了，转都不要给它转到。
X 跟这个 rotation 那这边的话呢，它是 X 跟 rotation。
没有 rotation 就不用，因为 roller 只是顶 X 而已。
所以这个就
没有说它 roller 是这样的，所以它只顶 X。如果 roller 是这样是顶 Y， 所以 roller 只是给你放东西在上面，它帮你顶住。
所以它现在是顶着 Y， 它是顶着 X 的。
对，它没有顶rotation。
所以 U1 就可以了。
Okay, so it was partially successful, yeah? So those 3 are no longer red and blue, but the other ones are a little bit bigger. So it means like the overall thing need to increase a little bit. And that's basically what we're trying to do. That's what the point of this activity is, yeah? Again, this question is not going to be on the exam. This type of question where you need to do too many iterations. This is just practice for you to play around with, yeah? But what we can get from this, it says recommend common structural shape and size. So what we did before was sizing exercise in order to produce cheapest and lightest structure. So, you can go with the big numbers, but they will be expensive. So you have to go reduce or start with small and start adding where you need. It doesn't really matter which way you go. Constraints are that minimum is sort of your below yield stress by factor of 3, and which means like 1/3 of your yield, and there should be no displacement. Yeah? So it's basically trial and error, trial and error. Yeah?
没有，你要放大一点。所以因为它是这整条，你不可以给它有这样，你给它这样的话，它这边会 bend。你可以 try 啦，你可以 try 一下，你 just 按 OK， 等你 按 OK， then 你 mesh， 没有是第二个，then 你 on yes， then 你就可以去弄你的 job。
这个我不是可以有个性。
你不需要 logo 是因为全部一样的。
哦。
So the yield is 300. Your limit stress will be 1. If you don't put any yield there, so you have to, let's say if you use particular alloy, particular steel, helps you work in yield stress.
But your this one quite balance because the grade one but I mean if you want you can change, you can make another property, you go property. Then you can reassign you make a bigger
So your first challenge is sort out the stress.
So you got this section where you create then you make a thicker cross section. Not so thick. A bit thicker than what you have. Then after that what you do is close, right? Then you assign. Now you know below this one. So just now you go delete your previous assignment. No longer. So you delete. No you delete. So you assign, right? So just now the only those two beams that are red, right? You don't assign. You assign all the other everything, right? As the first one. Then your second one is the higher beam. Just control A everything. You choose everything, then you control all control. Then you this one you choose the first one. Then now this two you choose the second one. Use. No, you must press button. Okay, so once this is done, like just submit your job. Then no you even that 300.
in job 1, 11 elements are missing property definition.
没有 complete 了。
Okay, so I'm after winning combination. So hopefully someone will be able to read out what are the sizes of each of those trusses that meet requirements. It's a bit of a challenge, I guess. Or
11
competition.
elements missing from property.
你有 assign 吗？你去看你的 table， 你去 check 一下你全部 table。
我这个放一个 trust 也可以啊，因为它整个都是 trust 嘛，所以我
没有，你这个你关掉，你的 assignment， 这个 assign trust， 你按这个，你按 edit， 你全部学了。
我不懂，要不然我可以重选。我按 OK
没有，
的。
你这是他是写什么？你那个 error 是什么？你
它有 element，
你刚才有改什么东西吗？但你那个名去换掉是吗？
东西名去换掉。
未必有改到什么名？
这个试一下。那个 composite layout 没有，就不用管它。
不用。你其他的你就在 trust 你就那3样在 property 要 take care， other than that 全部都没有叫你活动。
这个
step 你有弄吗？你有弄的话，你去看你的。
这个 off 跟 MD 是正常的吗？还是？
没有这个不要管，没有你按了你其他的 setting 你都不会动到的。
Tensile and U is different, right? I think it's tensile strength and yield strength.
No, yield strength is how much the stress can bend. So tensile stress, right, is how much the thing is pulled. So if the thing, sorry.
So the yield strength, so define the yield strength. CT factor is 3 parameter.
Yeah, so you need to take your the yield stress, right, from the material, which is example 800. So you need to divide by 3.
The material.
Yeah, so then your material stress, when you have your bending stress, right, your bending stress cannot be like that figure that divided by 3. You cannot reach that figure.
Now we get tensile strength.
Sorry?
Material is
No, you find you control.
It's a different problem. But it's actually a lot of exercise. Okay, let's go. Let's finish this. Sooner we finish, sooner we go home.
那是什么？
那你们是加一些。
你按你的 S A， 你 Control A， 你 Enter， 你先 Trust， 对，然后你 OK， 然后你再 reassign 那个 mesh， 对啊，你要 assign 你的 mesh。
是我的 sorry， 我 assign mesh 的意思是讲说我 just mesh part 就可以
对啊，
了。
按 mesh 吧。
然后我 just
然后你 just 去找上面。
是这样。
然后 KD 啊。
再画 KD。
就是就是
这个是那个消磨的。
第一个在因为这个是比较做只是这个那个完这个我是说我得看或者拍个year so it was a triangle.
Has anyone managed to solve it yet? Do we have size for 1, 2, 3? All of them? Not yet.
所以他应该要，我觉得他塞是什么塞都不知道。我应该要找那个 cross section 的也是对啊。所以你要他要 balance 全部stress 都比差不多一样。所以那个麻烦的地方在哪里？对啊，它又让很慢。
还有一个 video 要去看。min inverse 还有一个 m naught。 That's all. 为什么我的 stress 哪里有 stress？ 因为我的跟你的是 stress， 还是一样这两个。我的是六十。
Top and bottom, you look at anything at the top and bottom, the red and the blue one is
But more than half is red and blue. The music is like almost half is like red and blue.
Sorry, should have warned you. Now, I guess you can finish that off at home and at some other time. But let's move on to this sort of sub question. You see that problem, same problem that we got here, and designers decided to use trusses to build it. And the assumption is it's going to be cheaper, easier to assemble, and so on. Yeah? Now, if we are to do the same job, but using beams, how would that look like? So essentially, what we have this pulley that is there, and around which we got a cable that connects to this grate or whatever that is box. Same thing here. And over here, we got a wall against which the structure is laying. If we have the same setup, but we are to use beams, how would that design look like? Yeah? So this is very similar to your project. What are you doing there with the convoy? Said, okay, now we've got the same situation. How are we going to solve it using trusses? And how are we going to solve it using beams? Here, we got this lift, and that's what's shown there is using trusses. Here, how are we going to solve it using beams? What would be most obvious solution? Here. The easiest one would be to run a beam that goes like that. Yeah? And we put, I don't know, let's say profile like that. Yeah? And we have to just size it right. It will do exactly the same job as what this structure does. What you may find out if you model that the size of this needs to be really big and it's heavy. So what would be the other thing that you could do to sort of simplify it a little bit or reduce the size of it? You may add, for example, another component like that. So just imagine what we had is this. Like that, and you've got a load attached to it. Yeah? So most of the stresses will be happening at the base. But if you add something like that, so this will help a little bit with that beam over here so that it does not need to be as steep. So you can see how that design exploration increases. We are adding components, and you may do something else. You may even have another bit that goes like that. I don't know. So the idea is to reduce the weight of it and therefore cost. But then you may argue, look, more components that are added, I have to weld here, I have to weld there, have to do those things. Well, that's something we can balance out the costs of manufacturing. And that's basically what FEA engineers do. So here's the problem. Let me come up with a design. Let me size it appropriately, and along the way to make sure that it's not too expensive. Yeah? So, maybe we can, because we don't have answers for that yet. So maybe for at home, before tomorrow, so the first thing tomorrow we can go through this again. So we figure out how much this costs in terms of what is the volume, what is the mass of the material that we need to buy, and then find a solution that does this in beam and see whether we can make it cheaper than what's here. Yeah? Are we clear on this? Do we sort of understand the idea? Yeah? So your exam is going to be, as I said, similar to this. I'm not going to ask you to do so many iterations. As I said, this is just practice. But you will be asked to say, okay, given this scenario, given this description of the problem, what is the boundary condition, what is the load, what is the appropriate element, what is the appropriate element size, and so on. What commonly could happen, and happens all the time, is when it comes to structures like this, we've got people, students, putting notes there and there. And the structure all of a sudden looks that, becomes wiggly, like that. And they said a structure failed. Structure did not fail, it was you who failed, who didn't model that right. Yeah? So be mindful of those things. So that is the decision that you have to make. What is the appropriate element size? Yeah? Same goes with the beams. That story, remember that story of having beam or having coin. That will be also something on a test. If you make beam elements too short compared to cross section, again, it's your failure as FEA engineer, not modeling that right. So small things like that. That's what we're going to look in your submissions. Yeah. Okay. Now, before we wrap up, questions on your project, because yesterday we stayed a little bit too late explaining bits and pieces. So, are there any other questions about that? Extension will be given till 1st of April. That's what we agreed on last night. So I have not updated Canvas yet, but we'll do that. Yeah? So remember what you need to do, yeah? Yeah, so reason why you're given extension is because of potential misunderstanding that was here. So you'll have conrolled design, and you have to do design using trusses, beams, 2D solid, 3D solid. Same story. You do sizing, one iteration, then you come back and improve it, second iteration, and so on, till you find solution that complies with the design requirements. Yeah? So overall, you will have at least 1, 2, 3, 4, at least 8 designs, but probably more. Because assumption is if you get it right after second iteration, you're finished it. But you probably have to do more than one. Similar to this problem. Very similar to that problem. Yeah? We didn't get it right after first attempt, so we tried several times.
现在
Yeah?
我要问他度
So-
plane strain 跟 plane stress 要不要再做一个？
By doing that, you'll have more experience
没有写。
using abacus, and that's basically how you learn. You know, if you build 200 models, you'll be more experienced than if you build only 3. And that's basically where we're going with this. Yeah? Yes.
So for the 2D solid elements, right? It was mentioned the plane strain and plane stress. So we only need to do one each.
One which is relevant. Yeah?
就是你的 stress 那个
No, I mean like we do one plane stress and one plane strain should be the minimum requirements, right?
Yeah. That's a good question. So, when it comes to two 2D solid, look, I can't yell anymore. When it comes to 2D solid, you got 2 options: plane stress or plane strain. You have to choose appropriate to your problem. Not everything can be plane stress, not everything can be plane strain. Yeah? And you have to differentiate between the two. So that's why I didn't say here use plane stress or use plane strain. It's like use 2D solid and listed the options. So you have to choose what is the correct, appropriate modeling type. If you want, you can choose the other one and see what the difference is. Yeah?
But is it okay if we don't use both of them, we just use 2D shell model?
There's no 2D shell. So that's another thing. So shell, although it is represented in 2 dimensions, is 3-dimensional object. Yeah? So if you got when we talk about when we talk about 2D solid, like when you got a structure, like this, it's a 3D box. What are we doing as a 2D solid? We are taking front of it,
没有是讲没有
and then we are saying we are ignoring this bit, 3rd direction. And we are saying we can ignore that because all the action that happened in this plane. And everything else continues, is the same through that thickness, through that direction. Yeah? So when we say plane stress, it means all the stresses are here in a single plane. And here is the 0 stress. Sorry.
像那个我们的那个老师
Zero stress. So there's nothing happening in that 3rd direction. That's what the plane stress is. Plane strain is the same story. Strain happens in a plane and there's no change of thickness through that. So that's the difference between them. Now when we're dealing with a 3D shell, if you have a solid that is thin, that's got 1 dimension much smaller than the other 2, like this. Like this is perfect example. That's shell. Yeah? 3 dimensions, much bigger than thickness. What do? Commonly, we model middle surface. Now, surface as object itself is 2-dimensional, but lives in 3-dimensional space. 2D solid lives in 2D space. Shell lives in 3D space. So imagine this that's got a 0 thickness, but it lives in space. Yeah? 2D solid doesn't live in 3-dimensional space, lives on a screen only. Yeah? That's a major difference. What shells do, they're really good at taking loads that are perpendicular to them. like this. Shells, they don't like to be loaded like that, like this. Yeah? If you got something that is like this and you load it, shells love it. Yeah? They can deal with the structures like this, but they are not designed for it. Yeah? And we can do that. I mean, we can explore that and see what will happen if we model this as a shell. But you will see it needs to be loaded like this. It's not going to be like that. Yeah? So that's the difference. So shell is 3D object, lives in 3D space. 2D solid lives in two-dimensional space. Yeah? Does that make sense? So there's no 2D shell. That doesn't exist.
刚刚 skip 完了 local lecture。
Okay. Now, any other questions about your project?
2D shell, and base stress. They asked us to do these three.
No?
Then he say, shell one is the
Well, you
most
want to go
accurate.
home? You're sick and tired.
He say shell is the most accurate. So,
So let's do that. Let's go home then. So tomorrow, 2 o'clock, yeah, we'll have probably 2 more tasks,
That
design
is,
activities,
I don't even need to do
and
the
that's
plane
it.
string
You'll
because
be
he say
ready
which
for
one
your
is.
exam.
Yeah, he say which one is the most accurate one you use. He say not for all scenarios. So you can only use plane stress.
calculate 呢？